So, dear students, we are here again with electromagnetic theory. This is lecture 2, and we'll discuss about the Gauss's theorem, Gauss's field law, and then we'll slowly move towards divergence. तीन चीज अब तक हमने डिस्कस किया है. One is divergence, and we have to also know in details about divergence, and then we talk about gradient, and we also talk about curl. All three are the mathematical tools to understand our higher concepts of electromagnetic theory. Suppose say you have a charge here at P, and I circulate this all concentric S1, S2, S3, and suppose many are, we have many shells, concentric shells, where at the center we have charge. If we have such case, then in the previous lectures and with your previous knowledge, we know that surface integral of ER is equal to Q by epsilon naught, as we discussed here. So it is same thing we are discussing here. We can say ER is a non-changing element in comparison to the variable of the surface area. So we actually can bring it out, and we ultimately have, for a circular sphere, the sphere is equal to 4 pi r square. This we discussed in various other lectures, that this is nothing but the spherical area of the sphere, and this can also lead to Coulomb's law. And apart from this, we can say whatever it may be here, this is E into area, and that should be equal to Q by epsilon naught. This is something not new, already known to you in details, but we have one concept here. Let's suppose say we have 10 such layers. So instead of integration, we can also confirm that to a summation of I is equal to 1 to 10 EI dot n hat del Si. So n also is I. So this is same thing what we have mentioned here, but we have a limit, much smaller limit here, and there also approximately we can say that is also equal to Q by epsilon naught. And any value of our, because this whole thing is equal to phi, which I have not mentioned here. So phi doesn't changes. Phi for shell S3, S2, S1 all remain same, because they are dependent only on the Q and epsilon naught, and not on the radius or the sphere. If not radius, then obviously not sphere, because this R is the only constant of the sphere. 4 pi itself is a constant, so r square, radius is changing and no change. That means any shell we have same phi, same flux evolving out. But one thing is very simple physically, that this is one of my E, this is another E, and this is another E. Electric fields are moving like this, and if you talk in terms of the, you are standing here to locate, this is my E, all my E's are going in this direction. If you see here, the expansion has increased. So if you see from this corner, this is what we have actually diverging. But story wise it's okay, I can say you it is diverging, but mathematically how to show that this is diverging? Remember, this is what we have, the surface area we are talking about, not volume. But now I'll go to volume instead. Here you talked about surface area, but when I talk in three-dimensional concept, like the one I am showing with the lines and in all directions, in this page I cannot show you 3 dimension, but one is coming towards me, one is going away from me, that is also possible there in of E. In that case, I cannot concentrate only with this area, I also have to concentrate to volume. That means this same value, which is my phi, is equal to rho. Rho is the surface charge density, volume surface charge density. Rho is equal to charge by volume. So you can say any volume, charge by volume is my rho, surface charge density. So if this is my rho, where they have mentioned here suffix del V, so del V I can consider Q. Instead of Q I can write rho V. So that has been implemented here, and epsilon naught remains in the denominator as usual. That means this V, del V, can be taken here, and this is going to lead to a new story for us. Here we found that the surface integral per unit volume. Actually, this is my flux per unit volume. What I'm talking, flux per unit volume. I can say like this also. Flux per unit volume is equal to rho by epsilon naught. So surface charge density by epsilon naught. So altogether story has changed. This is what we can say here about the beginning of our concepts of divergence, but till now we are very much into Gauss's law, and with this only we'll enter to divergence. Now see here, if I give limit as usual in the previous my mathematical tool classes, I already talked in details about how we convert summation to integration. Yes, we are giving limit to this, and if you give limit to this, this is the integration sign here. Of course, I give limit of del v tends to 0, means v is becoming, volume is becoming the difference of the volume. In other words, I'll say it here again. If I go to the previous page, see the volume, this is one volume, next volume is this, next volume is this. When I say del v tends to 0, limit del v tends to 0, del v tends to 0, I mean to say the very consecutive next to next to next to next, all this very nearby the volume I am considering, where the gap is very less between the volume. In that case, I can come up, I can evolve with my concepts of my divergence. So here this is the case where we can say this is equal to del v tends to 0, and in that case I can say simply this is the function of x, y, z, because the volume charge density is of course a function of coordinates, x, y, z coordinates. So I am talking about that. Now we'll see this figure. You can see, suppose say you have a point here at center, what is the coordinate is x, y, and z. You have x, y, and z. If you have such case, you have S1 surface below and S2 surface up, or any just opposite. That means from here to here, from this point to this point, this is my x. If this is my y, suppose say, let me give example. Let me give example of S1 and S2, as this is my x direction they are showing. So S is in this direction and S2 in the back side. Let me consider that. So the point here is x, and here from here to the wall of the cuboid is my del x. It is in this direction, and from here to there until the other end, there is minus del x. That is showing the difference of minus del x. So you see how we mathematically change it. Now we are entering to understand divergence very carefully. Once we talk about divergence, we should be very clear that we are talking about divergence. So div f, now see, same thing can be implemented by f, because see there should not be any confusion. F by q is equal to q naught is equal to E. So I can say also F by E, if for one electron this is E, F by E is equal to E. So that is also possible. So in that case, if this is E, you simply divide that by F by E. E is a fixed number, because you know this is 1.6 into 10 to the 19, so you can get a fixed number, so there is no problem. You can easily write wherever you have for E, you can write same thing for F, because you are simply dividing that by multiplying that by E. If you divide this value, this E is equal to this, so multiply this by this, you get F. It's all the same thing. I hope you understand this. Now once you talk about div, we call this as div of F, where you have limit del V tends to 0. See the fun. Actually this is equal to 5. This is equal to 5. So you can't say exactly 5, because we have done some manipulation this way, that way. So if this is 5, rather you can say this is 5 by volume, 5 per unit volume. So if it is 5 per unit volume, so that means del the volume tends to 0. You are going for minute level. In that case, you have a condition like this, and we call it div. That means you have a charge somewhere here, and this volume and this volume, and if you just look here, it is getting divergence. To understand this, let's come back to this concept. Here we have this F. This is, I hope, no doubt in this. So we can say div E is equal to rho by epsilon naught. It's all the same thing. We can do both way. It's all the same thing. But now here elaborate. Suppose this is my f. Please remember this figure very carefully. We are going to derive with this figure. So here fx, function of x, y, z, I am considering only fx. That is the force along the x direction. Though I know force is also in y direction, force is also in z direction, I will consider one by one. So if I consider force along fx along x, y, z, then what I'll find? I'll find here that this is my fx is equal to x plus del x by 2, because x is already existing here. X is already existing because of the coordinate at this point, and del x is the total length of this. Del x is the total length of this. This is my del x. So this half from this point, as the point is in middle point, so this is my del x by 2 and that is my del x by 2. So here for this side I sum up, add up x plus del x by 2. X is already my existing coordinate, and because where the existing, the keyword is existing, and inside the keyword I have del x is the side of the x-axis, so I can say half of that is being added up. That is my fx, x and y and z. And we also have del y and del x, because three-dimensional concept we are taking. So fx is being, as in vector form you say I, j, k. We are here in coordinate system, we are clearly taking del x by 2, x plus del x by 2 is the coordinate instead of x, and my y and my z, and in return we have for that y, del y and del z, because del y and del z will be counted when you talk about x, because that will be along the x-axis. So in summary we can write this and another one. This is my first case, and with s2, my other side, back side, we have minus of the same thing, but that is minus of del x by 2, but all are same. There is no difference at all in this. Similarly, we can find out for fx, xyz and fz, xyz. We get exactly symmetrical structures here, and with this we can develop a very serious equation. We can say f(s1, s2), you can see here very clearly f(s1, s2) is going to give you a clear picture. You have here, this is my 1, plus and minus you add up together, and this del y del z comes, and when you add up both the plus and minus, you have done this, you do some manipulation, you divide this by del x and multiply this by del x. So you have done nothing, this and this, you have done nothing actually, you have done almost nothing. So what you have done here, you invited this and you invited this, so they cancel each other, it remains exactly what it is. On the other hand, you say s1 plus s2, when you add up both plus and minus, you get a structure like this. Just see carefully, because this is nothing but volume. This x, del x, del y, del z, product of height, length and breadth is volume. So this becomes in all del v. So del v is taken in the denominator of that side, so that is going, this is plus, please remember this, s1 plus s2. So this is my ultimately going to give you this. I hope you remember this structure. This is for function, difference of function, addition and minus. This is my condition for the differential form, integration form, if you go by that concept. Now if I go by this, then my left hand side is already in with limit. If I give this, here also limit comes, but limit of del x tends to 0. This is nothing but this whole thing. If I give in bracket, this whole thing is nothing but one single thing, ddx of f. This is nothing but ddx of f. Similarly, I can find out ddx y of fy and ddz of fz. So if I have three-dimensional concept, this is talking about volume, remember. If I talk about at s, not s1, s2, s3, s4, all this stuff, the whole sum, I add up all, I get in, that will be very lengthy deduction. If you go for calculating out that, we can, in summary, we can get this equation where we have all the three, and that is actually our dive is. So in summary, the moral of the story is this, what we call as dive. Dive is nothing but x, y and z differentiation of a function. div of f is equal to d del del x of fx plus del del x of y of fy and del del z of fz. So that is what we have to understand very clearly, and then you come with an example. Fx is supposed equal to ix square plus jxy plus kyz. This is very important for you all to understand and interpret the meaning. So from a function they are saying fxyz is equal to this function. Please try to interpret vector notation in matrix and also in calculus, because that is the only application we are going to do in future. So here, if I differentiate this in terms of x, I get only 2x because the rest will vanish. And if I differentiate this del del y, I get only x. And if I differentiate this with del del z, so I get only y again, because z will be 1 and k will be remaining there. It doesn't matter much for us. So that means div f is actually del del x of f, del del y of fy and del del z of fz. So you add up them, and div of f will be 3x plus y. Now this is mathematically easy, but physically one has to interpret. See the placing of this in a coordinate system and see the placing of this in a coordinate system. When I talk about divergence of such a system, if I first talk about placing of such a function in the coordinate system, what I get? I, j, k, I is with I. If you remember in my first or second lecture, I talked about some numericals and we entangled same type of numericals, and they has to be interpreted in the coordinate system. So if x is equal to 0, that is in the origin, this is 0, this also 0, but this remains. That means some function has been given to you where the yz is not 0. Something in yz plane always exists when x is also 0. Try to understand. Now let's increase the value of x. Let's consider y to be equal to 0. If y is 0, then this exists and both of them vanishes. And if z is 0, then two things exist, this and this both exist. Now we talk about, that means if x is 0, let's consider a case. X is equal to 0 and y is also equal to 0 and z is also equal to 0. If x is 0, function is, for x 0, function becomes, this is 0, this is 0, so k, y, z for f0. And when x is, y is 0, so this becomes, both of them are 0, only I x square. So I x square. If we differentiate this, we know we take magnitude of this because this is a vector now. These things I don't need to explain, I think so. At this level, you understand them very clearly. These are now your language, you can understand them very clearly. And if fz, suppose, and 0 of course, fz will be, if you differentiate, I'm not talking about differentiation, I'm talking implementation in the coordinate system now. So z is equal to 0, it remains as I x square plus j xy. Only this vanishes. So xy remains. That means we have plane which is actually xy even at the origin. We never start of such function at the origin. It remains when xy, see, everything becomes 0. If x is 0 now, y is 0 now, and z is 0 now, everything becomes 0. Obviously at origin everything will be 0. But if for z is 0, we have some value, a plane is being shown. This is a plane. If we, as per our divergence concept we have used so far, if we implement that concept, then we have one concept here, that f is, divergence of f is equal to this. So this is going to 3x plus y. So it's a plane actually. It's an xy plane where component of 3 is more and component of y is component of x is more and component of y is less. That means that is what we talked about. Similarly, we can implement the same concept of divergence with our, this is my div, I can write this as div of E is equal to this value. So you can easily find out, if you have f, you can also find out for E, and very easily you can calculate out all these concepts. So this is how our divergent concepts arises, and physically we can see that when you differentiate in all three dimensions, then we get divergence. It's quite natural. If you have something here, you differentiate x, y, z directions, you have to do three-dimensional differentiation, and that is our divergence is. This is divergence. So why you get divergence? Because it's like a beam of torchlight. So in simple words, if I use a simple word to make you understand divergence, I'll show you a coordinate diagram, so that will be making it much clearer. You'll just instantly understand what I want to say here. Suppose say you have a coordinate system like this and like this, and you have one, I'll change color to make you understand much clearly this concept. Suppose say you have one area like this, so area like this, next is the area like this, area like this, and next is area like this. They're not touching each other. They're three different lamina where size is increasing slowly in the coordinate system. Then starting from 0, and we have the size increasing slowly like an artistic piece. That means this is the inner one, inner lamina, then outer, next, and all the three laminas without any contact between them. In all the cases you can see the x, y, z three coordinates are increasing. So this type of condition is very much clear, will make you very much clear to understand divergence. This lamina is obviously bigger than this, and bigger than this, and bigger than this, and this is smallest, and at origin of course we have smallest. This type of conditions are actually exhibiting divergence. But this type of conditions, if you want to express mathematically, then we have to explain in such a way that volume, because we are talking about totalitarian. Here I am explaining small. Suppose this lamina, the first lamina number 1, is small part of a very big sphere. That is possible. Second one is also part of a very big sphere. But in general, we have to take volume. We cannot talk about only area. Though here we are talking about area, but we are talking about volume in general. So only then, when volume tends to 0, remember this side volume tends to 0, and this side the del x tends to 0. What is del x? You consider one direction. See, this is for one case, S1 and S2. In general, you are not mentioning anything because you add up. So you also have one case where x tends to 0, y tends to 0, del x tends to 0, sorry, del y tends to 0, and del z tends to 0. And that is physically happening. If these two lamina, this lamina 1 and lamina 2, suppose I name them, and they're very nearby, then all three del x, del y, and del z are obviously tending towards 0, and that means del v is tending to 0. So that is what, when the condition, we can talk about divergence, where even minute changes we record. So that is what the differentiation of in terms of x, y, and z we are mentioning here, and that is going to give you divergence of a vector quantity. Thank you. Any doubt? Please ask me doubt, and if you subscribe, you will get the latest video upload. Though due to lack of time, I sometimes cannot upload so many videos. So I think so. I won't talk like a typical, YouTuber. You subscribe, share, and all these things. If my concepts are good, you'll obviously see, and you'll obviously share, and you also will obviously subscribe. So I don't need to tell you anything. You can see yourself. Thank you so much.